Hello guys, I am Ranjan Misra and we are going to discuss compound microscope. Before we discuss compound microscope, you have to learn the simple microscope that we already discussed on the channel, and I have given the link in the description box. You can see the simple microscope. After that, please see this video. Okay. By simple microscope or by compound microscope or by telescope, in all three instruments, basically we increase the visual angle. Visual angle is angle subtended at our eye. We increase the visual angle. Okay, now let us understand and derive the magnifying power for compound microscope. Okay, in compound microscope there are two convex lenses. One lens is smaller and other lens is larger. Okay, one lens is smaller and other lens is larger. In this side we see the image, so it is called eyepiece. Eyepiece will be larger, and this is called objective because object is placed here. In this side object is placed, so we say it objective. The basic function, the basic strategy, we can say for microscope and telescope both, we make image from this lens in focal plane of eyepiece. Simple, we make image of objective lens in focal plane of eyepiece, and eyepiece make the image in same direction as virtual image and enlarged image. As we know that if a object is placed between optical center and focus, then image will be enlarged and virtual. This is the concept that is utilized. That is, this lens is always a simple microscope that we have discussed already. Okay. Now let us first draw the ray diagram. Let's have a object here. Let's have an object here. Then see the trick. First make the image in this plane and then start in reverse direction. Let it be this. First image, first line, and it will go like this. Okay. Now second image, second line, let it pass like this and go like this, and the final image will be formed here. Okay, this final image can be anywhere. This is VE. This can be from D to infinity, anywhere. Okay, this is the basic ray diagram. Okay, just now. Good. This is the object. That means it is H, and this is the image, first image. Say it H dash and make this as a theta. Okay, then this is UE because this image will act as an object for this lens, so it will be UE, and this is a image B naught for the first lens. Okay, simple concept. Now see the theta, tan theta, that will be theta will be equal to perpendicular H dash upon UE, the first theta. And from simple microscope we know that theta naught is H, and this is D. So theta naught is h upon D. Okay. Now the main purpose of this instrument, compound microscope, is to increase the angular magnification, and so we will calculate the magnifying power. First derivation is magnifying power. Magnifying power. And it is defined as visual angle with instrument, that is theta, okay, and visual angle without instrument. Visual angle without instrument, that is theta naught. So magnifying power will be theta upon theta naught, and we have already calculated theta and theta naught. So put the value MP. Theta is h dash upon UE upon theta is h upon D. Okay, so it will be h dash upon UE into D upon h. Now we can write that MP equal to h dash upon h and D upon UE. Okay, and from simple microscope already we know that h dash upon h equal to minus V upon U. Okay, so we can put here MP equal to minus V upon U and D upon U. This is the final result, and now we will discuss for two cases, far point, and now we are going to discuss two conditions for far point and for near point. Okay, far point means the final image. This is the final image VE. If this VE is formed at infinite, okay, if VE is at infinite, we have formula 1 upon VE minus 1 upon UE must be equal to 1 upon FE. In this case, it will be minus infinite because image is formed in left side and object is also in a left side. So it will be minus UE and that is equal to FE. 1 upon infinite is 0. From here, UE will be FE. Okay. In this case, magnifying power will be V upon U into D upon Fe. Okay, and tube length, see the tube length, the distance between the objective lens and the eyepiece is called tube length, and that is called L. L is what? V plus UE. In this case, L will be V plus Fe. Okay, this is the case when final image is formed at infinity. Okay, this is called far point. That means for far point, the magnifying power will be minus V upon U D upon Fe. And when final image is formed at least distance of distinct vision, like if final image VE is formed at minus D, then we can say that 1 upon D. I am using the same formula, and it becomes minus 1 upon D minus of 1 upon U equal to 1 upon Fe. From here, 1 upon UE will be equal to 1 upon D plus 1 upon FE. But in magnifying power, D upon UE is there. So multiply both sides by D. Multiply both sides by D. Then we will get D upon UE equal to 1 plus D upon FE. And magnifying power is this, minus V upon U, D upon UE. So MP magnifying power will be minus V upon U into 1 plus D upon FE. This is the magnifying power for near point. This is called near point. That is, this has been discussed when final image is formed at D. That means least distance of distinct division. This is the basic discussion of compound microscope. Thank you.